GCE Advanced Level Chemistry Practical Series, practical number 16, testing the solubility of salts of S block elements. The aim of this practical is to provide you with the necessary skills and knowledge to identify the salts of S block elements that precipitate in water when reacted with common anions. So, without further ado, let's move on to the reagents we will be using for this practical. Students, to conduct this practical, we'll be needing 5 different S block elements ions, and to obtain these ions, we will be taking their nitrates. So, why do we take their nitrates? Because nitrates of all of the S block elements are highly soluble in water. So therefore, to obtain potassium 1+ ions, we will be taking potassium nitrate. To obtain magnesium 2+ ions, we will be using magnesium nitrate. To obtain calcium 2+ ions, we will be using calcium nitrate. To obtain strontium 2+ ions, we will be using strontium nitrate. And finally, to obtain barium 2+ ions, we will be using barium nitrate. With that out of the way, let's move on to identifying the other reagents we will be using for this practical. We will be using sodium chloride, sodium bromide, sodium iodide, sodium hydroxide, sodium sulfide, sodium nitrite, sodium nitrate, sodium carbonate, sodium bicarbonate, also referred to as sodium hydrogen carbonate, sodium sulfate, sodium sulfite, sodium oxalate, sodium phosphate, and sodium chromate. Observe the color of sodium chromate. Now students, when I was introducing these solutions, you might have noticed all of these solutions were aqueous salt solutions of sodium. Why do we take sodium salts here? Now, these solutions are used to introduce different types of anions into these cations. So, why do we use sodium salt solutions to introduce the anions that are here? The main reason is sodium is forming all soluble salts, or actually any group 1 element. All of the salts of group 1 elements are soluble in water except for some salts of lithium, such as lithium fluoride, lithium carbonate, and lithium phosphate. Those salts are not soluble in water. However, all of the group 1 elements salts are soluble in water. So it is quite suitable to take sodium salts to introduce the necessary anions into these cations that we have here. Keeping that in mind, I will move on to the next few items we will be using in this practical. We will be using droppers to obtain small amounts of these solutions, and we will be using labeled test tubes so that we can very clearly identify which cations we are referring to. With that, let's move on to our practical. In this part of the practical, we will be focusing on taking these cation solutions and reacting them with halide ions. So as you know, we have 5 different cations here, 1 group 1 cation and 4 group 2 cations. As we know, group 1 cations, in this case we have taken potassium nitrate, group 1 cations will react with any common anion and will always form soluble salts. They will form water soluble salts, with the exception of course some salts in lithium that I mentioned earlier. So whatever that we add onto potassium ions in this experiment, you would notice that they do not produce a precipitate. However, you will notice when it comes to group 2 cations, most of the group 2 cations will not produce a precipitate with uni-negative anions. Uni-negative anions such as chlorides, bromides, iodides, or the halides, hydroxides, bicarbonates, they will not produce precipitates. But some cations will produce precipitates with certain anions. So let's first start with halides. We have here sodium chloride, sodium bromide, and sodium iodide. We will take small amounts of them and will add to our cation solutions and we'll see if they produce any precipitates. So let's take a small amount of potassium ion solution. This is a potassium 1 plus aqueous ion solution. As you can see, all of these salt solutions are colorless. We will take small portions of all of these cation aqueous ion solutions into labeled test tubes. As they are all colorless, having a label on the test tubes will help us identify what they are. Now students, we have taken small amounts of potassium 1 plus ions, magnesium 2 plus ions, calcium 2 plus ions, strontium 2 plus ions and barium 2 plus ions into 5 different test tubes, as you can see here. Now we will be starting to add small amounts of sodium chloride to each of these test tubes, and we are going to notice if there are any precipitates formed when we are adding sodium chloride or when we are introducing chloride ions into this medium. This is our sodium chloride solution. We'll use a small dropper, and this is our potassium 1 plus ion solution, and let's add a drop or few drops rather of sodium chloride to see if there is a precipitate formed when adding sodium chloride. As you can see, upon addition of sodium chloride into potassium 1 plus ion aqueous solution, we did not form a precipitate as expected. Now we have our magnesium 2 plus ion solution. To that also let's add a few drops of chloride ions solution. So you can see upon addition of few drops of chloride ion solution, we did not form a precipitate. Again, we expected this outcome because majority of the group 2 cations do not form precipitates with most of the uni-negative anions, and especially halides do not form any precipitates with any of these cations. But let's move on ahead and add sodium chloride to all of these cations just to observe what happens. So right now I am adding sodium chloride to calcium 2 plus aqueous solution. You can see there is no precipitate formed. There are no traces of any precipitate. We have a strontium 2 plus ion solution. Let's add a few drops of sodium chloride. As you can see, when you add a few drops of sodium chloride to strontium 2 plus aqueous ions, there is no precipitate formed. Finally, we have our barium 2 plus aqueous solutions. So let's add a few drops of sodium chloride to that as well. And let's shake it. You can see there are no traces of any precipitate here. As expected, when chlorides or when chloride ions are mixed with these cations, we will not be forming any precipitate. Potassium chloride, magnesium chloride, calcium chloride, strontium chloride, and barium chloride that is formed here are soluble in water. So therefore, you would not observe any precipitates formed here. Let's move on to bromides. Now, we have taken all of our cation solutions into 5 different test tubes, and we have labeled these test tubes so that we can clearly identify them. To these cation solutions, we will be adding sodium bromide to introduce bromide ions into each of these solutions. So let's take each of these test tubes. We have potassium ions here, and we have our sodium bromide here. Let's add a few drops of sodium bromide to potassium ions and see what happens. As you see, students, upon addition of bromide ions into potassium ions, there is no precipitate formed, indicating the potassium bromide that is formed here is soluble in water. Now we have our magnesium. To magnesium 2 plus ions, I am now adding a small amount of bromide ions. Do you observe a precipitate here? The answer would be no. What you form here is magnesium bromide. Magnesium bromide is also soluble in water, so therefore you will not see a precipitate formed there. We have our calcium 2 plus ions. Let's add a small amount of bromide ions into calcium 2 plus ions. Again, calcium 2 plus ions, when reacted with bromide ions, forms calcium bromide. This is also soluble in water and will not form a precipitate. We have strontium 2 plus ions here. If we add a small amount of bromide ions into this and give it a little mix, you can see even when it comes to strontium 2 plus ions reacted with bromide ions, we will not form a precipitate because the strontium bromide formed is soluble in water. Finally, we have our barium ion solution. Let's add a little bit of bromide ions to barium. and let's mix it up. You can see when barium is reacted with bromide, you form barium bromide. Even barium bromide is not forming a precipitate because barium bromide is soluble in water. As you can see, when bromide ions were reacted with these cations, we did not form any precipitates. Let's move on to iodide ions. Like in the previous part of the experiment, we have a new batch of our cation solutions taken into 5 different test tubes, and we have labeled them. And to these test tubes, or to these cation solutions, we will be adding sodium iodide. We have here our sodium iodide. We will be adding small amounts of sodium iodide into each of these cation solutions. Let's take our potassium 1 plus aqueous ion solution and add a little bit of sodium iodide. As you can see, when potassium is reacted with iodide ions, it forms potassium iodide. This salt is a soluble salt in water, so therefore you will not see a precipitate. We have here our magnesium 2 plus ion solution. To that, I am adding a small amount of sodium iodide. And as you can see, when magnesium ions are reacted with iodide ions, we form magnesium iodide, which is also not forming a precipitate. Since magnesium iodide is soluble in water, you can see we do not observe a precipitate. We have our calcium 2 plus ion solution here. Let's add a small amount of sodium iodide into this. Now you can observe, when I add sodium iodide into calcium 2 plus ion solution, we do not see a precipitate. Calcium ions along with sodium iodide will form calcium iodide. And calcium iodide is soluble in water, so therefore you will not see a precipitate. Then we have our strontium aqueous ion solutions, strontium 2 plus. Let's add I minus ions, iodide ions. When strontium 2 plus ions come into contact with iodide ions, they also do not form a precipitate, as strontium iodide is soluble in water. Now finally we have barium 2 plus aqueous ion solution. To that, let's add a small amount of iodide ions. Barium ions along with iodide ions will form barium iodide. Barium iodide is also a soluble salt. It's a water soluble salt. So therefore, it will also not form a precipitate. As you can see, it's a clear solution, no precipitate formed. So students, as expected, all of the iodide ions, when reacted with these cations we have in front of us, did not form a precipitate, indicating all of these iodide salts that are formed when iodide ions are reacted with these cations are water soluble. This, in summary, tells us all of the halide ions, when reacted with these cations, group 1 and group 2 cations, when they are reacted with our halide ions that are present here, they do not form any precipitates. Let's move on to sodium hydroxide. We have here new portions of all of the cation solutions taken into 5 different test tubes. And to these test tubes, we will be adding sodium hydroxide. So, when you add sodium hydroxide, you will notice that the group 1 cations do not form any precipitates. All of the group 1 cations, when reacted with hydroxide anion, will form soluble salts. However, group 2 cations, when reacted with hydroxide ions, will not always form soluble salts. Solubility of the group 2 hydroxides increase down the group, and solubility of group 2 hydroxides such as magnesium and calcium are actually not that high. That means they will form precipitates, but as you go down the group 2 hydroxides starts to become more and more soluble. Let's see if we can make that observation here. To represent the group 1, we have our potassium 1 plus ions. Let's add a small amount of sodium hydroxide and observe if potassium hydroxide that is formed here produces a precipitate. So we have potassium 1 plus ions here along with hydroxide ions in this medium. You can see they do not form a precipitate. This indicates potassium hydroxide do not produce a precipitate. Similarly, all of the group 1 element hydroxides are soluble in water. Let's move on to magnesium 2 plus aqueous ion solutions. This is a group 2 cation. Let's add a little bit of sodium hydroxide. As you can see, upon addition of sodium hydroxide, let's add a little bit more. We form a white color precipitate. We have here magnesium 2 plus ions reacting with hydroxide ions forming magnesium hydroxide. So, group 2 cation magnesium 2 plus when reacted with hydroxide ions forms a white color precipitate. This is magnesium hydroxide insoluble in water. Let's give it a little shake so that you can very clearly see the color of the solid suspension that we have here. We can see this is not a white color solution we have. What we have here is fine magnesium hydroxide precipitate particles dispersed through the aqueous medium, making this entire aqueous medium cloudy. So what you see here is magnesium hydroxide, which is a white color precipitate that is insoluble in water. Now, let's move on to calcium 2 plus ions. And let's take a small amount of sodium hydroxide and add sodium hydroxide into our calcium 2 plus ion solution. As you can see, upon addition of sodium hydroxide to calcium 2 plus ions, there is a small precipitate that is formed. It's a very small quantity, but there is a small white color precipitate that is forming at the bottom. When calcium 2 plus ions are reacted with hydroxide ions, it forms a white color precipitate that is calcium hydroxide. But keep in mind, students, calcium hydroxide is not completely insoluble in water. It is sparingly soluble in water. So very small amount of the calcium hydroxide precipitate that is formed here is dissolved in this aqueous medium. So let's mix this precipitate up to have a bit of a more clear observation, you can see now the solution becomes cloudy as the precipitate gets dispersed throughout the aqueous medium that we have here. So again, keep in mind the calcium hydroxide precipitate that is formed here is not completely insoluble in water but sparingly soluble in water. Sparingly soluble means a small amount of the calcium hydroxide that is formed actually dissolves in water, but majority of it remains as a precipitate. Let's take our strontium 2 plus aqueous ion solution and add a small amount of sodium hydroxide and observe what happens. Let's add it drop by drop. And let's observe what happens when you add sodium hydroxide to strontium 2 plus aqueous ion solution. As I told you before, solubility of group 2 hydroxides increases down the group. However, strontium hydroxide, which is formed here when we react strontium 2 plus aqueous ions with hydroxide ions, we form strontium hydroxide. Strontium hydroxide is not completely soluble in water. In fact, it is sparingly soluble. So, if you leave this out for a while, you will see a white color precipitate forming here. But this reaction will happen slowly. You will notice the formation of the precipitate very slowly. So, let's keep shaking it for a while. You'll observe the formation of the precipitate little by little. You can see here very small precipitate particles sinking to the bottom. It's a very clear observation. Small particles of strontium hydroxide precipitating to the bottom is very clearly observed here. So again, this let us know that strontium hydroxide that is formed is sparingly soluble in water. It is not completely insoluble. It is sparingly soluble in water. Small amount of strontium hydroxide that is formed actually dissolves in water, but there is also a portion of strontium hydroxide that is not soluble in water. However, strontium hydroxide is more soluble compared to calcium hydroxide and magnesium hydroxide. Now, let's take barium 2 plus aqueous ion solution and add a small amount of sodium hydroxide. We'll add it drop by drop. And now, let's give it a small shake. We'll mix it well to see if a precipitate is formed. As you can see, upon addition of a small amount of sodium hydroxide, let's add a small amount of sodium hydroxide again. You can see, upon addition of a small amount of sodium hydroxide, we do not form a precipitate here. There is no formation of a precipitate. So, when barium 2 plus ions come into contact with OH minus ions or hydroxide ions, you see they form barium hydroxide, which is soluble in water. This indicates when you're going down the group 2 hydroxides are becoming more and more soluble in water. Now let's move on to see a small summary of how the cations we have here reacted with sodium hydroxide. As you saw earlier, when we reacted sodium hydroxide with potassium, 1 plus ions, we formed potassium hydroxide, which was completely soluble in water. So you can see there was no precipitate. Magnesium hydroxide, that is formed by reacting magnesium 2 plus ions with the hydroxide ions, was insoluble in water. A white color precipitate was formed. Due to the very fine nature of the precipitate, you can see the precipitate is dispersed throughout the aqueous medium, and therefore you can see a cloudy nature over here. What you see here is the insoluble magnesium hydroxide precipitate. Then we took a small amount of calcium 2 plus and added sodium hydroxide to this. You can see calcium 2 plus, when reacted with hydroxide ions, forms a calcium hydroxide precipitate. Calcium hydroxide is sparingly soluble in water. That means a small amount of calcium hydroxide actually dissolved in water. The remainder of the precipitate can be observed at the bottom of the test tube. This is a white color precipitate. Then we have here our strontium 2 plus aqueous solution reacted with hydroxide ions. We have strontium 2 plus aqueous ions reacted with sodium hydroxide. And as you can see, strontium hydroxide that is formed did give us a precipitate. This precipitate is also sparingly soluble, and you can see strontium hydroxide crystals very clearly formed here. Strontium hydroxide is also sparingly soluble in water. That means a small amount of strontium hydroxide that is formed here is dissolved in the aqueous medium. However, strontium hydroxide is a bit more soluble in aqueous medium than calcium hydroxide. And finally, we have our barium hydroxide solution here. So we have our barium 2 plus aqueous ions reacted with the sodium hydroxide, and you can see barium hydroxide did not produce a precipitate. The reason for this is that the barium hydroxide is a water-soluble hydroxide. So therefore, it is not going to produce a precipitate in water. We have here potassium 1 plus ions reacted with sodium hydroxide. If you keep this aside, the remainder of the test tubes contain group 2 cations. As you know, when you go down the group 2 hydroxides, the group 2 hydroxides become more and more soluble as you go down the group. And that is also clearly visible here. Magnesium hydroxide has magnesium hydroxide white color precipitate, which is quite insoluble in water, has quite a bit of precipitate produced here. We have calcium hydroxide sparingly soluble in water, strontium hydroxide sparingly soluble in water, and barium hydroxide, which is soluble in water. So solubility of these hydroxides increased down the group, producing less and less precipitate. Let's take a look at what happens when sodium sulfide is added to these cation solutions. We have taken small portions of each of these cations into 5 different test tubes, as you can see here. And now we are going to add sodium sulfide to each of these test tubes and observe what happens. So let's take a dropper. Let's take a small dropper and take a small amount of sodium sulfide and add a few drops of sodium sulfide into our potassium nitrate solution. So we have our potassium 1 plus aqueous ion solution obtained with the use of potassium nitrate, and to that we added sodium sulfide. And when we mix it, you can see there is no precipitate formed. Do we see a precipitate formed here? We see a clear solution. The reason for this is when potassium ions come into contact with sulfide ions, what is formed is potassium sulfide. Potassium sulfide is a soluble solid or soluble salt. It dissolves in water and therefore it does not form a precipitate. Now we can move on to magnesium 2 plus ions. Again, we obtained this magnesium 2 plus aqueous ion solution with the help of magnesium nitrate. So what you see here is magnesium nitrate, and magnesium 2 plus ions are in the medium, so we can introduce sulfide ions by addition of sodium sulfide into this. So let's take a small amount of sodium sulfide. So when I add few drops of sodium sulfide, that introduces small amount of sulfide ions into this test tube. Now let's mix it well and see if magnesium ions, when in contact with sulfide ions, whether it forms a precipitate. As you can observe here, we do not form a precipitate when magnesium 2 plus ions come into contact with sulfide ions. As magnesium ions form magnesium sulfide is water soluble and therefore will not form a precipitate. We have here calcium 2 plus aqueous ion solution. Again, we obtain this calcium 2 plus aqueous ion solution with the use of calcium nitrate. So to this, let's add a few drops of sodium sulfide. As you can see, upon addition of sodium sulfide, we did not see a change. Let's mix it really well and see if that brings about a change. No. In the presence of calcium 2 plus ions and sulfide ions, we form calcium sulfide. Calcium sulfide is water soluble. So therefore, you do not see formation of a precipitate. What we have here is strontium 2 plus ions. Again, we obtain this strontium 2 plus aqueous ion solution by dissolving strontium nitrate in water. Now to this strontium 2 plus aqueous ion solution, we are adding sodium sulfide to introduce sulfide ions into this reaction mixture. When you add sodium sulfide, we did not see a precipitate forming. Let's mix it really well. As you can see, even after mixing it well, we do not see a formation of a precipitate. Strontium sulfide that is formed is soluble in water, so therefore no precipitate is observed. We have here a barium 2 plus aqueous ion solution obtained through barium nitrate. To that, we'll be adding a small amount of sodium sulfide. Now I have added a small amount of sodium sulfide here. Do you observe a precipitate being formed or any color change? The answer to that would be no. As barium 2 plus ions come into contact with sulfide ions, they form barium sulfide, which is soluble salt, a water soluble salt, so therefore you will not observe formation of a precipitate. In summary, we observed When group 1 cation that we have here, potassium ions reacted with sulfide ions, we do not form precipitate. And all of the group 2 cations that we have here, when treated with sodium sulfate, did not form a precipitate. Let's move on to sodium nitrite. In this part of our experiment, we'll be focusing on how nitrite ions and nitrate ions react with these cations. To each of these test tubes, we have taken cations that we looked at earlier in the earlier parts of the experiments as well. So, as you can see, we have our potassium, magnesium, calcium, strontium and barium cations solutions taken into 5 different test tubes, and we actually have 2 sets of those test tubes. This is to compare what happens when we react each of these cation solutions with nitrite ions and nitrate ions. Let's take a look at what happens when we react each of these cation solutions with nitrite ions. To introduce nitrite ions into our cation solutions, we are going to be using sodium nitrite. So we have our sodium nitrite ion solution here. First, we will take a small amount of potassium 1 plus aqueous ion solution, and we will add few drops of sodium nitrite. Upon addition of nitrite ions into potassium 1 plus ions, we do not see a precipitate being formed. This is because the potassium nitrite that is formed is soluble in water. In fact, all of the group 1 nitrites are very soluble in water. Let's take magnesium 2 plus aqueous ion solution. To our magnesium 2 plus aqueous ion solution, we are adding a small amount of sodium nitrite, drop by drop. When magnesium 2 plus ions react with nitrite ions, it produces magnesium nitrite. Magnesium nitrite is soluble in water, so therefore we do not see the formation of a precipitate. We have our calcium 2 plus aqueous ion solution. To that as well, we will add a small amount of nitrite ions by adding sodium nitrite into the mixture. You can see calcium ions, when reacted with nitrite ions, form calcium nitrite, which is soluble in water, so therefore it will also not form a precipitate. Over here, we have our strontium 2 plus aqueous ion solution. Let's add a small amount of sodium nitrite. When we introduce nitrite ions into a strontium 2 plus ion solution, we form strontium nitrite. Strontium nitrite is soluble in water, so therefore you will not see the formation of a precipitate. As you can see, we have a clear solution, no precipitate formed. When it comes to barium, we have a barium 2 plus aqueous ion solution. To that, let's add a small amount of nitride ions, drop by drop, and let's mix it really well. And you can see we do not form a precipitate here as well, as barium ions and nitride ions form barium nitride, which is soluble in water. The salt barium nitride is soluble in water, so therefore you will not see the formation of a precipitate. With this experiment, we observed that all of the nitrides that we had here were soluble, starting from potassium to barium, when potassium ions, magnesium, calcium, strontium and barium ions were reacted with nitrides, we saw they did not form precipitate. In fact, both the group 1 and group 2 elements do not form precipitates with nitride ions. Let's move on to nitrate ions. So we have our sodium nitrate solution here. Using this solution, we will introduce nitrate ions into our cation solutions. Let's take new samples of each of our cation solutions here. So we have potassium, magnesium, calcium, strontium and barium ion solutions that are not reacted with anything else at the moment. So to that, we will be adding nitrate ions. To add nitrate ions, as I mentioned before, we will be using sodium nitrate. Let's take our potassium 1 plus aqueous ion solution and add nitrate ion solution and see what happens. As you can see, when nitrate ions are added to potassium ions, we form potassium nitrate, which is soluble in water. In fact, all of the group 1 nitrates are soluble in water. Let's move on to a group 2 element, magnesium 2 plus aqueous ion solution. To that, let's add a small amount of sodium nitrate. We added a small amount of sodium nitrate into magnesium 2 plus aqueous ion solution. As you can see, upon addition of nitrate ions into magnesium 2 plus solution, we do not see the formation of a precipitate. We form magnesium nitrate here, and we do not observe a precipitate being formed upon the addition of nitrate ions. Now, let's move on to calcium 2 plus aqueous solutions. Let's add a small amount of nitrate ion solution into calcium 2 plus. Calcium 2 plus, when reacted with nitrate ions, will form calcium nitrate. Calcium nitrate is also very soluble in water, so therefore you will not see the formation of a precipitate here as well. Let's move on to strontium. Strontium 2 plus aqueous solution. Let's add a small amount of sodium nitrate into strontium. And then let's shake it really well. Now you can see when strontium 2 plus aqueous ion solutions come into contact with nitrate ions, they form strontium nitrate. Strontium nitrate is also very soluble in water, so therefore you will not see the formation of a precipitate here as well. You can see the solution is clear. Finally, we move on to barium 2 plus aqueous ion solutions. And when I add a small amount of sodium nitrate, you can see we did not form a precipitate here as well. Barium 2 plus ions, when they come into contact with sodium nitrate or nitrate ions, they will form barium nitrate. Barium nitrate is soluble in water, so therefore you would not see the formation of a precipitate here. Students, in summary, we have our cation solutions that were reacted with nitrite ions here on the right hand side, and on the left hand side we have our cation solutions that were reacted with nitrate ions. In both instances, we observed no precipitates were formed. This means all the S block elements do not form precipitates with nitrates and nitrites. Let's move on to the next experiment. Now, let's take a look at how carbonate anions and bicarbonate anions react with the cations that we have taken for this practical. In this practical, we are taking a look at potassium, magnesium, calcium, strontium and barium cations. So we have taken 5 test tubes with these cation solutions. Actually, we have 2 sets of these test tubes, as we are going to be comparing the observations that we get when we react carbonate ions and bicarbonate ions with these cations. Let's first take one set of these cation solutions and start adding carbonate ions into each of these cation solutions. We have here sodium carbonate, and let's take a small amount of sodium carbonate and add a small amount of sodium carbonate into potassium 1 plus aqueous solutions. Now we are adding sodium carbonate to potassium 1 plus ion solution. As you can see, there is no precipitate formed. Potassium 1 plus ions, when reacted with carbonate ions, will not form a precipitate. All the group 1 cations, when reacted with carbonates, will not form a precipitate as they are water soluble, except for lithium carbonate. Let's move on to magnesium. We have magnesium 2 plus aqueous solution here. Let's add a small amount of sodium carbonate into this. Do you see? When I add sodium carbonate drop by drop to magnesium 2 plus aqueous solution, we formed a white color precipitate. So when magnesium 2 plus ions come into contact with carbonate ions, they form magnesium carbonate, which is a white color precipitate. Carbonates of group 2 are not soluble in water. Actually, group 2 carbonates decrease in their solubility in water as you go down the group. So what you see here is a formation of magnesium carbonate upon addition of carbonate anion into magnesium 2 plus ions. It's a white color precipitate. Let's move on to the next cation. We have here calcium 2 plus aqueous ion solution. Let's add a small amount of sodium carbonate. You can see upon addition of sodium carbonate or carbonate ions into calcium 2 plus ion solution, we saw a white precipitate was formed. Again, as I mentioned earlier, as you go down the group of group 2 carbonates become more and more less soluble in water. So calcium 2 plus ions, when reacted with carbonate and ions, they form calcium carbonate, which is a white color precipitate. Over here, we have strontium 2 plus aqueous ion solution. Now, take a guess. Before we add the carbonate and ion into strontium 2 plus aqueous ion solution, what would be the observation? What do you think you would see? If you guessed a white color precipitate will be formed, you are correct. Let's add a small amount of sodium carbonate. As you can see, when you're adding sodium carbonate drop by drop, a white color precipitate is formed. When strontium 2 plus ions come into contact with carbonate and iron, they form strontium carbonate, which is a white color precipitate. Finally, we have barium 2 plus aqueous ions. Let's add a small amount of sodium carbonate into this as well. As you can see, just like in the previous 3 experiments, when I added carbonate ions into barium 2 plus aqueous ion solution, we formed a white color precipitate. This is due to the formation of barium carbonate. Barium 2 plus comes into contact with carbonate and ions and form barium carbonate, which is a white color precipitate, and this barium carbonate is insoluble in water. Solubility of the carbonates of group 2 compounds will decrease as you go down the group. So, as you can see, except for the group 1 element that we have here, so we have a potassium 1 plus ion solution. When reacted with carbonates, we did not see the formation of a precipitate. But except for that, all the group 2 carbonates produced precipitates. Let's move on to bicarbonate and ions. Here, you can see to 5 different test tubes we have taken these cation solutions that are labeled here. We have potassium, magnesium, calcium, strontium, and barium cation solutions taken into these 5 different test tubes. To that, let's add sodium bicarbonate. Let's add sodium bicarbonate. Let's take our potassium aqueous ion solution and let's take a small amount of sodium bicarbonate and add a few drops of sodium bicarbonate into our potassium 1 plus aqueous ion solution. So by adding sodium bicarbonate, we introduce bicarbonate ions into this reaction mixture. So now this solution contains potassium ions as well as bicarbonate ions in the mixture. So you can see the formation of potassium bicarbonate. Potassium bicarbonate is water soluble. Therefore, you will not see the formation of a precipitate. Potassium bicarbonate is water soluble and no precipitate is observed. Now let's take magnesium 2 plus aqueous ion solution. If you remember, just a little while back, when we added carbonate anions into magnesium 2 plus aqueous solution, a white color precipitate was formed. Let's observe what happens when we add bicarbonate anion solution here. Now, we will take a small amount of bicarbonate anion solution and we are adding few drops of bicarbonate anion solution into magnesium 2 plus aqueous ion solution. What is observation? Do you see the formation of a white color precipitate? No. In the previous situation, when we added the carbonate anion to magnesium 2 plus, we saw the formation of a white color precipitate. But we will not see the formation of a white color precipitate when we add bicarbonate into magnesium 2 plus aqueous ion solution. Let's take our calcium 2 plus aqueous ion solution, and to that let's add a few drops of sodium bicarbonate solution. As you can see, when you add sodium bicarbonate into calcium 2 plus aqueous ion solution, we do not form a precipitate. In the presence of bicarbonate ions, calcium ions will form calcium bicarbonate. Calcium bicarbonate is water soluble. Here we have our strontium 2 plus aqueous ion solution. To that, we will take a small amount of bicarbonate ion solution and we will add it drop by drop onto strontium 2 plus ion solution. Do you observe the formation of a precipitate? The answer would be no. Strontium 2 plus aqueous ions, when they come into contact with bicarbonate anions, will form strontium bicarbonate, which is a water soluble salt. So therefore, you will not see the formation of a precipitate. Finally, we have our barium 2 plus aqueous ion solution. Barium 2 plus aqueous ion solution, when treated with sodium bicarbonate. Let's see what happens. I added a few drops of sodium bicarbonate to barium 2 plus aqueous ion solution, and now I'm mixing it. You can see we did not form a precipitate. Barium 2 plus ions forms barium bicarbonate with the carbonate anion. Barium bicarbonate is a water soluble salt. So therefore, you will not see the formation of a precipitate. Now students, we saw these cations, when reacted with the bicarbonate anion, formed bicarbonate salts that were soluble in water. Starting from potassium to all of the group 2 cations we have here, they formed bicarbonate salts that were soluble in water. Before this experiment was done, we took the same cation solutions and reacted these cation solutions with sodium carbonate. And we saw, except for the potassium 1 plus ion solution, the rest of the cations formed carbonates that were insoluble in water. Actually, the solubility of carbonates of group 2 compounds decrease as you go down the group. Now let's compare each of these solutions. You have magnesium 2 plus aqueous solutions reacted with bicarbonate anions, did not form a precipitate on my right hand side, and on my left hand I have magnesium 2 plus aqueous solution reacted with carbonate ion solutions. You can see the formation of white color magnesium carbonate precipitate. On my right hand, I have calcium 2 plus aqueous ion solutions reacted with bicarbonate anions. You can see it did not form a precipitate. On my left hand, I have calcium ions reacted with carbonate anion forming calcium carbonate white color precipitate. Then we have strontium. We can see the same trend here as well. Strontium ions, when reacted with bicarbonate, did not give us a precipitate, so therefore you can see a clear solution here. But strontium ions, when reacted with carbonate anions, formed a white color strontium carbonate water insoluble precipitate. Finally, barium 2 plus ion solutions. On my right hand, you see here barium 2 plus ions reacted with bicarbonate ions, did not form a precipitate. On my left hand here, you can see barium 2 plus ions reacted with carbonate anions forming barium carbonate white color precipitate. Let's take a look at how sulfate anions and sulfite anions will react with these cation solutions. Just like in the previous parts of our experiment, we have 5 different cation solutions: potassium, magnesium, calcium, strontium and barium are cation solutions. We actually have 2 sets of test tubes containing these cation solutions. To the first set of test tubes containing these solutions, we will be adding sodium sulfate. So sodium sulfate will introduce sulfate ions into each of these cation solutions. So let's take potassium plus aqueous ion solution, and to that let's add a small amount of sodium sulfate. Now when I'm adding sodium sulfate into this solution, I'm introducing sulfate anion to potassium ions. You can see when I added sulfate ions to our potassium ion solution, we did not form a precipitate. In the presence of sulfate anion, potassium ions will form potassium sulfate, which is soluble in water. Now let's move on to magnesium 2 plus ion solutions. We'll take a small amount of sodium sulfate and introduce sulfate ions by adding few drops of sulfate ion solution into magnesium ions. In the presence of magnesium ions, sulfate ions will form magnesium sulfate. Magnesium 2 plus and sulfate ions will get together and will form magnesium sulfate. Magnesium sulfate is soluble in water. So therefore, you will not see the formation of a precipitate. However, solubility of sulfates in group 2 decreases down the group. As you go down the group, the sulfates of group 2 compounds decreases down the group. So now let's observe what happens when you move on to calcium 2 plus aqueous ion solutions and add a small amount of sodium sulfate. When we add sodium sulfate to calcium 2 plus aqueous ion solution and mix it, we make the calcium 2 plus ions come into contact with the sulfate anion. Calcium 2 plus and sulfate anions together will form calcium sulfate. You can see very slowly forming a white color precipitate. Calcium sulfate is a sparingly soluble white color precipitate. It is not completely insoluble in water. However, the precipitate that you form is slightly or sparingly soluble in water. Small amount of the calcium sulfate precipitate has dissolved in water. The remainder is dispersed in water, making this aqueous medium cloudy. Due to the fine calcium sulfate precipitate particles, you can see the aqueous medium here is appearing cloudy. And you can now see the precipitate particles are collecting at the bottom due to gravity. So keep in mind, magnesium sulfate was completely soluble in water. Calcium sulfate was sparingly soluble in water. Now, we are moving on to strontium 2 plus aqueous ion solution. Let's add a few drops of sodium sulfate. So now I'm introducing sulfate ions into our strontium 2 plus ion solution. As you can see, as soon as a small amount of sodium sulfate was added to strontium 2 plus ion solution, we started forming a white color precipitate. This white color precipitate is insoluble in water. What we have formed here is strontium sulfate, which is a white color insoluble precipitate. Strontium sulfate. So this indicates the solubility of sulfate keeps on decreasing as you go down the group 2 cations. Finally, we have our barium 2 plus aqueous ion solution. Let's take our barium 2 plus aqueous ions and add a small amount of sulfate anion. As you can see, as soon as even a drop of the sulfate anion solution was added, a white color precipitate was formed. Let's add a few more drops. We can see a very clear white color precipitate formed when barium 2 plus is reacted with sulfate anion. What you see here is a formation of barium sulfate precipitate, which is white in color. Barium sulfate is insoluble in water. Actually, out of the sulfates that we have formed here, barium sulfate is the most insoluble in water. As we saw here, solubility of group 2 sulfates decreased as you go down the group. You can see group 1 sulfates were soluble in water. We can see magnesium sulfate formed here. You can see we do not see a precipitate here, meaning magnesium sulfate was soluble in water. In this test tube, we have calcium sulfate formed. Calcium sulfate was sparingly soluble in water, meaning a small amount of calcium sulfate was dissolved in water. Over here, we have strontium sulfate formed. It is insoluble in water. And finally, we have barium sulfate, that is the most insoluble out of the sulfates that we have here. These are all white color precipitates, and this is what happens when we react sulfate ions with S block cations. Now, let's move on to sulfite ions. We'll keep this aside for the time being, and we'll take a new set of samples of each of the cations. Let's take our potassium 1 plus aqueous ion solution and add a small amount of sodium sulfite. Now sulfite ions will be introduced by the addition of sodium sulfite into potassium plus aqueous ion solution. Now you can see what happens upon the addition of sodium sulfite. Potassium 1 plus ions, when in presence of sulfite anion, will form potassium sulfite. Potassium sulfite is a salt that is soluble in water. So therefore, you will see that this solution is not producing a precipitate. There will be no precipitate present when reacting potassium ions with sulfite anion. Now let's move on to group 2 cations we have here. We have a magnesium 2 plus aqueous ion solution. To that, let's add a small amount of sodium sulfite. We'll add a few more drops of sodium sulfite. Magnesium 2 plus ions, when in contact with sulfite anion, will form magnesium sulfite. Magnesium sulfite is a white color precipitate that is sparingly soluble or slightly soluble in water. It takes a while for the precipitate to be formed, so let's shake this test tube for a while until we observe the formation of a precipitate. As you can see, a white color fine precipitate particles are being formed here in this test tube. For comparison, let's take a clear test tube close to it so that you might be able to observe the white color precipitate being formed. The amount of precipitate you observe here will be very minimal because some amount of the precipitate dissolves in the aqueous medium, as magnesium sulfite is sparingly soluble in water, meaning certain amount of magnesium sulfite produced here will dissolve in the medium. You can observe the precipitate particles present in the aqueous medium suspended very clearly now. If we set it aside for a while, you will be able to notice the precipitate collecting at the bottom. So when we are doing the summary for this particular part of the practical, you will be able to observe the precipitate a little bit more clearly. Now, let's move on to calcium 2 plus aqueous ion solution, and let's add a small amount of sodium sulfite into this medium. You can see when sodium sulfite is added, it forms a white color precipitate. I have not yet mixed this precipitate yet, but you can observe in the presence of calcium 2 plus ions, you can observe that when sulfite ions are added to calcium 2 plus, it forms calcium sulfite, which is forming a white color precipitate that is insoluble in water. We have calcium sulfite formed here, that is insoluble in water. We'll add a few more drops to increase the precipitate we have here, and then you can see a very clear white color precipitate that is formed here. The entire aqueous medium appears white as calcium sulfite fine precipitate particles are dispersed in the aqueous medium, making the entire medium appear white. Now, let's take our strontium 2+ aqueous ion solution. And to it, let's add our sodium sulfite. By adding sodium sulfite, we introduce sulfite anion, and you can see as I add sulfite anions into strontium 2+ aqueous ion solution, a white color precipitate started to form. This is strontium sulfite, which is a white color water insoluble precipitate. To see the color very clearly, let's add a little bit more sodium sulfite to increase the precipitate. Now you can see, due to dispersion of fine white color strontium sulfite precipitate particles, this entire aqueous medium appears white. Now we move on to our barium 2+ aqueous ion solution. Let's add a small amount of sodium sulfite. You can see as we added sulfite ions into barium 2+ aqueous ion medium, we formed a white color precipitate as seen before in the previous example as well. Barium 2+ when in contact with sulfite ions will form barium sulfite, which is a white color water insoluble precipitate. Now let's move on to the summary. When we reacted these cations that we have in front of us with sulfite ions, we saw potassium did not form a precipitate. When you reacted potassium ions with sulfite anion, we formed potassium sulfite, which was water soluble and therefore did not form a precipitate. Then we added sulfite anion to magnesium 2+ aqueous ion solution. You can see a fine precipitate is formed here, and some of the precipitate dissolved in water as magnesium sulfite is water soluble. So we have magnesium sulfite is sparingly soluble in water, which means small amount of the precipitate that is formed dissolves in water. If you are comparing what happened when magnesium 2+ ions were reacted with sulfate anion, on my left hand I have magnesium sulfate solution. You can see when it was reacted with sulfate anion, it did not form a precipitate because magnesium sulfate was soluble in water. But magnesium sulfite is sparingly soluble in water. Then we took a small amount of calcium 2+ aqueous ion solution, reacted it with sulfite anions. We saw the formation of a white color calcium sulfite precipitate. when comparing it to the previous experiment we did, that is calcium 2 plus ions reacted with sulfate anions, we formed calcium sulfate, which is also a water insoluble white color precipitate. So on my right hand side, I have calcium sulfite. On my left hand side, I have calcium sulfate precipitate. Both are forming precipitates in this instance. Then we took small amount of strontium 2 plus aqueous ion solution and we added small amount of sulfite anion solution into this, and we formed strontium sulfite, which is a white color precipitate. When we are comparing what happened when we added strontium, when we are comparing what happened when we added sulfate anion into strontium 2 plus aqueous solutions, you can see even when we added sulfate anion into strontium 2 plus, it formed a white color precipitate. So in both instances, when strontium was treated with sulfite and sulfate anion, they formed white color precipitates. And finally, we took a small amount of barium 2 plus aqueous ion solution, reacted it with sulfite anion and obtained barium sulfite white color water insoluble precipitate. In comparison to the previous experiment, you can see on my left hand we have barium 2 plus ions reacted with sodium sulfate. So on my left hand test tube, what you are seeing is the barium sulfate precipitate. On my right hand, I have the barium sulfite precipitate. Both precipitates are white color precipitates. So when you react barium 2 plus ions with sulfite, you produce barium sulfite, which is white color precipitate. When you react barium 2 plus ions with sulfate anion, you produce barium sulfate, which is also a white color precipitate. These are the reactions that you see when you react these cations that we have with sodium sulfate and sodium sulfite. Let's move on to see how these cations react with the oxalate anions. Let's take a look at how oxalate anions react with the cations we have in front of us. Just like in the previous parts, we will be taking a look at potassium, magnesium, calcium, strontium and barium cations, and we will be reacting oxalate anions with these cations. Let's take our sodium oxalate solution here, and let's take a small amount of sodium oxalate and add it to our potassium plus aqueous ion solution. So we have our potassium 1 plus aqueous ion solution here. And let's see what happens when a drop of oxalate anion solution is added. As you can see, when you add oxalate anion, you do not see the formation of a precipitate. Potassium ions along with oxalate anion will form potassium oxalate, which is a water-soluble salt. So therefore, you will not see the formation of a precipitate. Please observe that potassium oxalate that is formed here does not form a precipitate. Now let's take our magnesium 2 plus aqueous ion solution, and we'll add a small amount of sodium oxalate. I added a few drops of sodium oxalate to introduce the oxalate anion into this solution. In this test tube, we have magnesium 2 plus ions along with oxalate anion. Magnesium 2 plus, in the presence of oxalate anion, will form a white colored precipitate, magnesium oxalate. Magnesium oxalate is slightly soluble in water. We say sparingly soluble in water. If you observe very closely, we can see the formation of fine magnesium oxalate precipitate particles in this solution. We will mix it up a little bit more and add a small amount of sodium oxalate again. We can see after shaking it for a while, we can see the formation of magnesium oxalate. Magnesium oxalate is a white color precipitate and it is sparingly soluble in water, which means certain amount of the magnesium oxalate precipitate that was formed here dissolved in the aqueous medium, and the remainder can be seen as fine precipitate particles that is dispersed or suspended throughout the aqueous medium, making this aqueous medium here look cloudy. So with the presence of oxalate anions, magnesium 2 plus will form magnesium oxalate, which is a white color precipitate. We have here our calcium 2 plus aqueous ion solution. Let's take this calcium 2 plus aqueous ion solution and react it with sodium oxalate. As you can see, when just one drop of oxalate anion solution is added, you can see the formation of a white color precipitate. Let's add a few more drops to see very clear. White color precipitate formed. If you shake it, you will see the precipitate will get dispersed throughout the aqueous medium and make it look like a white color solution. But in fact, this, what you have here, is calcium oxalate precipitate particles suspended in the aqueous medium. So calcium 2 plus ions in the presence of oxalate anion forms calcium oxalate, which is a white color precipitate. Then let's move on to our strontium 2 plus aqueous ion solution. Let's take our strontium 2 plus aqueous ion solution and add a small amount of sodium oxalate. Again, you might see upon addition of just one drop, we have a white color precipitate formed. Let's add a few more drops. And now you can very clearly see the formation of a white color precipitate when we added oxalate anions to strontium cations. This means strontium 2 plus in the presence of oxalate anion forms strontium oxalate, which is a white color precipitate which is insoluble in water. Finally, we have our barium 2 plus aqueous ion solution. Let's take our barium 2 plus aqueous ion solution, and just like we did before, we'll add a small amount of oxalate anion solution into this barium cation solution. You can see as soon as you add a small amount of oxalate anion to barium 2 plus cation solution, we form a white color precipitate. Barium 2 plus in the presence of oxalate anion will form barium oxalate, a white color precipitate. Barium oxalate is a white color precipitate which is sparingly soluble in water. You can see the color very clearly. Now students, let's take a look at the summary of what happened when we reacted oxalate anions with the cations we have in front of us. When we reacted potassium plus cation with oxalate anion, we saw that we did not form a precipitate because potassium oxalate that is formed in here was water soluble. The salt potassium oxalate is soluble in water. Then we reacted magnesium 2 plus ions with oxalate anion. We formed magnesium oxalate, which was a sparingly soluble precipitate. A white color precipitate was formed. The name of the precipitate is magnesium oxalate, which is sparingly soluble in water. Then we took calcium 2 plus ions, reacted it with oxalate anion, and we saw the formation of a white color precipitate, which is calcium oxalate. Calcium oxalate is a white color precipitate which is insoluble in water. Then we moved on to strontium 2 plus aqueous ion solution, reacted it with sodium oxalate, formed strontium oxalate, a white color water insoluble precipitate was formed. Finally, we took barium 2 plus aqueous ion solution and added sodium oxalate and formed barium oxalate, a white color precipitate. Barium oxalate that is formed here is also sparingly soluble in water. This is how the cations that we have here reacted with the oxalate anion. Let's move on to phosphate anion. Let's move on to see how phosphate anion reacts with these cations. So we have here solutions of potassium 1 plus ion, magnesium 2 plus, calcium 2 plus, strontium 2 plus, and barium 2 plus ions taken into 5 different test tubes. Now let's add small amounts of phosphate anion and see what the observations are. We have here our sodium phosphate solution. Using this solution, we will be introducing phosphate anions into our cation solutions here. Let's first take our potassium aqueous ion solution, potassium 1 plus, and add a small amount of sodium phosphate or phosphate anion solution. As you can see, when I add phosphate ion solution drop by drop to potassium 1 plus aqueous ion solution, it does not form a precipitate. The reason why you do not see a precipitate is potassium ions, when reacted with phosphate ions, it will be forming potassium phosphate. Potassium phosphate is water soluble and therefore it will not form a precipitate. Now we move on to magnesium 2 plus aqueous ion solutions. We have here our magnesium 2 plus aqueous ion solution, and to that, just like in the previous test, we will be adding a small amount of phosphate ion solution, sodium phosphate. Now you can see here, when I started adding phosphate ion solution to magnesium, immediately a white color precipitate was starting to form. What you see here is magnesium phosphate. When magnesium ions come into contact with phosphate ions, it forms a white color precipitate, magnesium phosphate. Let's add a few more drops to see the precipitate clearly. You can see the white color precipitate particles of magnesium phosphate here. Magnesium phosphate is a water-insoluble white color precipitate. Now, let's move on to calcium 2+ aqueous ion solution. To this calcium 2+ aqueous ion solution, we will be adding sodium phosphate, like in the previous experiment. And you can see, upon addition of a single drop of sodium phosphate, a precipitate is starting to form. We added a few more drops to see the precipitate very clearly. Before shaking this mixture, you can see the calcium phosphate precipitate that is formed very clearly here. And now, what you observe here is calcium 2+ ions, when coming into contact with phosphate anion, forms calcium phosphate, which is a white color precipitate. That is why the suspension appears to be white. Let's move on to strontium 2+ aqueous ion solutions. We have here our strontium 2+ aqueous ion solution. To that, we will be adding phosphate ions. You can see when sodium phosphate solution is added, a white color precipitate is formed. You can very clearly see the formation of a white color precipitate here. So when strontium 2+ ions come into contact with phosphate ions, they form strontium phosphate, a white color, water-insoluble precipitate. If I shake it, these precipitate particles will be suspended in the aqueous medium, forming a white color suspension here. So what is the color of strontium phosphate? It is a white color, water-insoluble precipitate. Now, we move on to barium 2+ aqueous ion solutions. To this barium 2+ aqueous ion solutions, let's also add sodium phosphate. As you can see, when you add sodium phosphate drop by drop, just like in the previous 3 group 2 cations, what you can see here is barium phosphate, a white color, water-insoluble precipitate formed. So now you can observe the color very clearly. Barium 2+ ions, when reacted with phosphate ions, forms barium phosphate, which is a white color precipitate. Now, let's take a look at the summary. We have here our group 1 element, potassium plus ions. Potassium plus ions, when reacted with phosphate anion, did not give us a precipitate. This is because potassium phosphate that is formed is water soluble. Then, the rest of the 4 test tubes contained group 2 cations. All of the group 2 cations, when reacted with phosphate anion, formed a white color precipitate. When you took magnesium 2+ aqueous ions and reacted with phosphate anion, it formed magnesium phosphate, a white color precipitate. When you took calcium 2 plus ions and reacted with phosphate anions, it formed calcium phosphate, a white color precipitate. When you took strontium 2 plus ions and reacted with phosphate anions, it formed a white color strontium phosphate precipitate. And finally, we took barium 2 plus ions, reacted with phosphate and formed barium phosphate precipitate. All these precipitates that are formed in the group 2 cations are water insoluble and white in color. That is how phosphate anions react with the cations we have in front of us. Let's move on to chromate anion. In this final part of our practical, we are going to be observing how chromate anions react with these cations. Again, we have taken potassium plus ions, magnesium 2 plus, calcium 2 plus, strontium 2 plus and barium 2 plus ion solutions into 5 different test tubes. And we will be adding sodium chromate into each of these solutions and observing what happens when chromate ions interact with these cations. Let's first take potassium 1 plus ion solution that we have here and add a small amount of sodium chromate. Now, before adding sodium chromate, please observe the color of the sodium chromate solution. Sodium chromate is a yellow in color. The reason for this yellow color is the chromate anion. Chromate anion is a colored anion and it has a yellow color. Now, we will be adding a small amount of sodium chromate to introduce the chromate anion into this solution. And after introducing it, let's mix it really well. And upon addition of the sodium chromate solution to potassium 1 plus aqueous ion solution, we observed the color of the potassium 1 plus aqueous ion solution changed to a yellow color. But we did not observe the formation of a precipitate. This indicates that potassium plus ions, when coming into contact with chromate anions, will not form a precipitate. However, since potassium chromate is soluble in water, you will have chromate ions in the medium. Chromate ions has their characteristic color, which is the yellow color present here as well. Just like in sodium chromate, over here in this solution as well, chromate ions are present without forming a precipitate. So therefore, the solution is yellow in color. Now, let's move on to magnesium 2 plus aqueous solutions, which we have here. To this magnesium 2 plus aqueous ion solution, we will be adding a small amount of sodium chromate. As you can see, upon addition of sodium chromate to magnesium 2 plus ion solution, it did not form a precipitate. However, you can see the solution turned a yellow color. This is because the chromate ions that are present in the medium, in the aqueous form, always gives out that yellow color. Aqueous chromate ions will always be visible as a yellow solution. Over here with magnesium 2 plus, since chromate ions do not form a precipitate, you have aqueous chromate ions present, giving us this yellow color solution. Magnesium 2 plus, when coming into contact with chromate, forms magnesium chromate, which is water soluble, so therefore no precipitate is seen. But due to the presence of aqueous chromate ions in the medium will appear to be yellow in color. Now we will be taking calcium 2 plus ion solution, and to this calcium 2 plus ion solution we will be adding sodium chromate. Upon addition of few drops of sodium chromate to calcium 2 plus, we see that we do not form a precipitate. Just like in the previous two examples, we are seeing a yellow color solution. This is because the calcium 2 plus ions in the presence of chromate anions will form calcium chromate, which is water soluble, which means the chromate anion is still present in this medium as an aqueous ion. An aqueous chromate anion will always give out a yellow color. That is why we observe this solution to be yellow in color here. Now we have our strontium 2 plus aqueous ion solution. Let's take a small amount of strontium 2 plus aqueous ion solution, and to that we will be adding sodium chromate. You can see as soon as we added just one drop of sodium chromate, it formed a yellow color precipitate. We'll add a few more drops. You can see the formation of a yellow precipitate when sodium chromate was added to strontium 2 plus aqueous ion solution. Let's mix it really well. When strontium 2 plus comes into contact with chromate anion, it forms strontium chromate. Strontium chromate is a yellow color water insoluble precipitate. So what you see here is fine particles of strontium chromate yellow color precipitate being dispersed in the aqueous medium, creating a yellow color suspension. This is not a yellow color solution. What you see here is a yellow color suspension of strontium chromate water insoluble precipitate. Finally, we move on to barium 2 plus aqueous ion solution. We have here our barium 2 plus aqueous ion solution, and to that we will be adding a small amount of sodium chromate. As you can observe, when just one drop of sodium chromate is added, a yellow color precipitate was formed. We'll add a few more drops. Upon adding a few more drops of sodium chromate, we saw that barium ions reacted with the chromate anion to form a yellow color precipitate. A pale yellow color precipitate is formed, and this precipitate is barium chromate. Barium chromate is a yellow color precipitate. Barium ions in the presence of chromate ions form a yellow color precipitate that is insoluble in water. Now let's move on to the summary of what happens when chromate ions are reacted with potassium, magnesium, calcium, strontium and barium cations. When chromate ions are added with potassium ions, we form potassium chromate, which is water soluble, so therefore no precipitate will be observed. But due to the presence of aqueous chromate anions in the solution will appear to be yellow. In magnesium 2 plus aqueous solution also, we saw a very similar observation, because with the chromate anion, magnesium do not form a precipitate, because magnesium chromate is a water soluble salt. Due to the presence of chromate anions in the medium, the solution will appear to be yellow. Then we moved on to calcium. Calcium also we saw the same observation. When reacted with the chromate anion, calcium will form calcium chromate, which is water soluble, meaning calcium ions and the chromate anion is present in this medium in the aqueous form, and aqueous chromate anions are yellow in color. That is why you observe this solution to be a yellow color solution. So in all of these three solutions you have in front of us, they appear to be yellow in color because these three ions have aqueous chromate anion present in them. Then we moved on to strontium. Strontium, when reacted with chromate, formed strontium chromate, which is a water insoluble yellow color precipitate. You can see a yellow color precipitate present in this test tube. This is strontium chromate. A yellow color water insoluble precipitate forms when strontium 2 plus reacts with chromate anions. And finally, when we added chromate anion to barium cation, we saw the formation of another yellow color precipitate, which is barium chromate. Barium chromate is also a yellow color water insoluble precipitate. This is how chromate ion reacts with the cations that we have here today. With that, we come to an end of today's practical. The important details pertaining to this practical, as well as some other theory parts, will be discussed in the next session.